When it comes to iconic national parks in the United States, Yellowstone is undoubtedly at the top of many people's lists. Known for its awe-inspiring geysers, most notably the majestic Old Faithful, its abundant wildlife, and its breathtaking canyons, Yellowstone has captivated explorers and tourists alike since its establishment as the world's first national park in 1872. But despite all this attention over the years, there's still so much about Yellowstone that we don't know. And now scientists are turning their sights to space in an effort to uncover some of the secrets lying beneath the park. Join us as we delve into the depths and discover what NASA and other space agencies are doing in the skies above Yellowstone. What they found there will make you question everything. Now, you might be wondering why Yellowstone? Why is it that space agencies like NASA are focusing their telescopes on this particular national park? Well, the answer lies in the unique geological history of the region. Yellowstone sits atop a massive hotspot, a particularly active area where magma plumes from deep within the Earth's mantle create a geothermal wonderland. This results in hundreds of geysers, hot springs, and fumaroles releasing superheated steam and gases. It's a mesmerizing spectacle that draws in countless visitors each year. But it's also a treasure trove of data for those looking to understand our planet better. By studying these geothermal features, scientists can peer deep into the Earth's crust and mantle, gaining insights into the inner workings of our planet that are impossible to achieve through traditional means. But Yellowstone isn't just about geysers. It's also home to some of the world's most diverse and abundant wildlife, from bison and elk to wolves and grizzly bears. Monitoring these populations from space allows researchers to track migration patterns, habitat use, and population dynamics over vast areas in near real time. This is crucial for conservation efforts and helps park managers make informed decisions to protect Yellowstone's precious biodiversity. In recent years, Yellowstone's hydrothermal areas have become a particular focus for space-based observation. These areas, which include geysers, hot springs, and fumaroles, are not only geothermal wonders, but also serve as valuable indicators of what's happening deep within the Earth's crust. Changes in their distribution, temperature, or gas emissions can signal shifts in the behavior of the magma plume, providing early warning signs of potential volcanic activity. In a region where earthquakes are frequent and volcanic history significant, this kind of monitoring is invaluable. One of the leading organizations at the forefront of this endeavor is NASA, the National Aeronautics and Space Administration. NASA's Earth Observing System, Land, Ice, and Fire, or the LOI and Fire program, is a prime example. This program utilizes various satellites equipped with sensors that can detect changes in land cover and surface temperatures. For instance, the Moderate Resolution Imaging Spectroradiometer, or MODIS instrument aboard NASA's Terra and Aqua satellites, scans the entire Earth's land surface every 1 to 2 days. By analyzing the thermal signatures emitted from the Earth's surface, MODIS can identify areas of high heat, such as those found in Yellowstone's geothermal features. Such monitoring helps scientists keep tabs on the health of these features, detect any changes over time, and provide valuable insights into their behavior. Another tool in NASA's arsenal is the Landsat program, a series of satellites that have been imaging the Earth's surface since 1972. Initially designed to monitor changes in land use and agriculture, the Landsat satellites have provided an invaluable archive of Yellowstone's changing landscapes. Every 16 days, the satellites capture images of the entire Earth's landmass, allowing researchers to study changes in vegetation, snow cover, and ice extent over the seasons and years. By comparing historical Landsat images with modern ones, scientists can track the evolution of Yellowstone's geothermal areas, helping them understand how these features change and adapt over time. Yellowstone National Park is vast, spanning over 2.2 million acres across 3 states, Wyoming, Montana, and Idaho. Its diverse landscape encompasses everything from dense forests and alpine meadows to rugged mountain peaks and vast geothermal areas. Managing a park of this size presents numerous challenges, from ensuring the safety of visitors to protecting its rich biodiversity and preserving its natural resources. That's where technology like unmanned aircraft systems, or UAS, commonly known as drones, come into play. Drones have revolutionized how we explore and monitor Yellowstone. Equipped with high-resolution cameras and other sensors, these unmanned aerial vehicles can access areas that are difficult or dangerous to reach by foot or vehicle. This allows for efficient and safe inspections of infrastructure, rapid assessment of damage from natural events like floods or wildfires, and detailed surveys of hard-to-reach geothermal features and wildlife habitats. Moreover, drones can monitor air and water quality, collect data on vegetation health, and provide valuable insights into the park's changing conditions. They even assist in search and rescue operations, providing an aerial view to locate individuals in distress. The use of drones in Yellowstone exemplifies how technology can enhance park management, research, and visitor experiences while ensuring the preservation of this unique ecosystem for generations to come. The next frontier in Yellowstone exploration is venturing even deeper beneath the park's surface. Scientists are now utilizing seismic monitoring to gain insights into the subsurface structure and activity beneath Yellowstone. Seismic monitoring involves placing seismometers, instruments that detect and record the strength and timing of earthquakes, at various locations across the region. By recording the arrival times of seismic waves generated by both natural and human-made sources, researchers can create maps of the subsurface layers and their properties. This is achieved by analyzing how the waves travel through different materials and how they are reflected or refracted at boundaries between different layers. These maps provide crucial information about the subsurface geology, including the depth to the bedrock and the thickness and composition of the layers above it. Understanding the subsurface structure helps scientists assess the potential risks of volcanic eruptions or earthquakes and provides a better understanding of the geothermal system beneath Yellowstone. Moreover, seismic monitoring allows researchers to study the movement of magma beneath the surface. By detecting even the smallest tremors, scientists can identify areas where magma is moving toward the surface, providing valuable insights into the behavior of Yellowstone's magma chamber. This information is crucial for predicting volcanic activity and assessing the potential impact on the surrounding areas. To further enhance their exploration efforts, scientists are also conducting drilling operations at Yellowstone. These drilling projects aim to retrieve rock samples and conduct various laboratory analyses to understand the subsurface conditions. The recovered samples provide direct information about the temperature, mineral content, and other properties of the rocks at different depths. By analyzing these samples, researchers can better understand the processes occurring beneath the surface, such as the production of geothermal energy or the interaction between magma and surrounding rocks. Additionally, drilling projects often include instruments to monitor parameters like temperature, pressure, and gas emissions. These real-time measurements provide continuous data on the stability of the subsurface environment and any changes that may occur over time. At Yellowstone, the scientific exploration doesn't stop at the boundaries of the park. Researchers are also investigating the surrounding areas to gain a broader understanding of the regional geology and potential impacts of volcanic activity. This includes studying the history of past eruptions, the extent of the Yellowstone caldera, and the potential hazards associated with future eruptions. To do this, scientists are conducting field work such as mapping the distribution of volcanic ash and other eruption deposits, as well as collecting and analyzing samples from these deposits. They are also using remote sensing techniques, such as aerial photography and satellite imagery, to identify and monitor changes in the landscape, including the growth of volcanic features. All of these efforts combined provide a comprehensive understanding of the Yellowstone supervolcano and its surrounding areas. By piecing together the various pieces of evidence, scientists can build a more complete picture of the park's history, its present-day activity, and the potential risks and opportunities that lie ahead. From tracking wildlife populations to monitoring geothermal wonders, and exploring the depths of its caldera, NASA and other space agencies are leaving no stone unturned in their quest to understand this extraordinary corner of our planet. As technology advances, we can expect even more fascinating discoveries from Yellowstone, reminding us of the boundless wonders that exist in our world. So keep your eyes on the skies above Yellowstone, because who knows what mysteries they might unveil next. What are your thoughts on the discoveries being made at Yellowstone? Do you think the findings from space missions will lead to more exciting revelations in the future? Share your thoughts in the comments below. Also, if you enjoyed this video and want to support our channel, please remember to like and subscribe. Your support allows us to continue exploring and bringing you amazing content. Thanks for watching.